Hello students, today we will discuss about elliptical orbit. That is, a particle moves in an ellipse under a force which is always directed towards its focus. So we have to find out the law of force, the velocity at any point of its path and the time period. First we will derive the law of force. The equation of an ellipse with focus as pole is given by L by R is equals to 1 plus E cos theta. We know this equation from our 12th standard class, where we have studied deeply about the ellipse, parabola, hyperbola. Where now in this equation, L is the semi-latus rectum and E is the eccentricity of the ellipse, such that eccentricity lies between 0 to 1 open interval. Taking u is equals to 1 by r, we have u is equals to 1 plus e cos theta by l. From this equation, we can derive l is equals to r is equals to l upon 1 by 1 plus e cos theta. So here u is equals to 1 plus e cos theta by l. Now differentiating this equation with respect to theta, we will get du by d theta is equals to minus e by l sin theta. Again differentiating with respect to theta, we will get d2u by d theta square is equals to minus e cos theta by l. The differential equation of central orbit in polar form is given by d2u by d theta square plus u is equals to f upon में h square plus u square, where f is the central acceleration. Now this differential equation in polar form, we have derived this equation in our previous lecture. So in equation number 3, we have to substitute the value of u and d2u by d theta square from equation number 1 and 2. After substitution, we get f upon में h square u square is equals to minus e cos theta by l plus 1 plus e cos theta by l. So cancelling the term minus e cos theta by l with plus e cos theta by l, we will get f upon में h square u square is equals to 1 by l. So shifting h square u square to numerator of right hand side, we get f is equals to h square u square by l. Now h square by l in u, now substituting the value of u, which is equals to 1 by r, we get f is equals to h square l into 1 upon में r square. Take h square by l as constant, which is lambda, we get f is equals to lambda upon r square. So here lambda is equals to h square by l. Now we are deriving the law of force. So from this equation, f is inversely proportional to square root of distance of the particle from focus. Also the force is attractive because the sign of f is positive. Now we have to find out the velocity. The velocity of central orbit is given by v square is equals to h square into du by d theta का whole square plus u square. This is the equation of velocity when the path is known. Now substituting the value of du by d theta and u, we will get h square into में minus e sin theta by l का whole square plus 1 plus e cos theta by l का whole square. Now what we are doing the square of denominator. In both the terms we have denominator l, so l square will be common in the denominator. So after squaring both the terms, we will get h square by l square into में e square sin square theta plus 1 plus e square cos square theta plus 2e cos theta. Now sin square theta plus cos square theta is 1, so we will get h square by l square into में e square plus 1 plus 2e cos theta. Now here h square is equals to lambda l. H square, substituting the value of h square. After substituting the value of h square, we will get lambda l by l square into में e square plus 1 plus 2e cos theta, cancelling lambda from numerator and denominator. Now in this bracket expression, add and subtract 1. Take the term 1 and 2e cos theta. in one bracket. So we will get lambda by में L bracket 2 into में 1 plus e cos theta minus 1 minus e square, taking minus common from both the terms, minus 1 and e square. So after this what we will get, we will get lambda into में 2 1 plus e cos theta by L minus 1 minus e square by L. So 1 plus e cos theta by L is our u, substituting the value u here, and from the definition of eccentricity and lattice rectum, from eccentricity and from L, we have 1 minus e square is equals to b square by a square, and L is our b square by a. So substituting the value of 1 minus e square and L over here, after solving we will get v square is equals to lambda into में 2 by r minus 1 by a. This is the equation of the velocity at any point of the ellipse, and this equation will depend upon the distance, that is r, from the focus and independent of the direction of motion. Also in this equation we have 2 lambda by r, and we are subtracting 1 by r from the term 2 lambda by r. So here v square is always less than 2 lambda by r. Now we will derive expression for periodic time. We know that in central orbit the rate of description of sectorial area is always constant and is equal to h by 2. We have derived expression for this article in our previous class. If t is the time taken by the particle in describing the whole ellipse, then h by 2 into t is equals to area of ellipse, which is pi ab. So t is equals to 2 pi ab by h. Now we know that h square is equals to lambda L, so h is equals to square root of lambda by L. Substituting the value of h in denominator, we will get t is equals to 2 pi a by b upon में square root of lambda L. Here substitute the value of L, which is equals to b square by a. Then we will get the expression for time period, t is equals to 2 pi a 3 by 2 upon में square root of L. Thus time period for one complete revolution is proportional to a की 3 by 2, where a is our semi-major axis. So these are the expression for force, velocity and time period when the particle is moving in ellipse under a central force, which is always directed towards the focus. Now we will be discussing same case when the particle is moving in hyperbola under a central force, which is always directed towards its focus. So polar equation of hyperbola referred to focus as pole is L by r is equals to 1 plus e cos theta, where L is our semi-lattice rectum and is the eccentricity of the hyperbola, which is always greater than 1. So substituting u is equals to 1 by r. From this equation we will get u is equals to 1 plus e cos theta by L, because r is L upon में 1 plus e cos theta. Differentiating this, the value of u with respect to theta, we will get du by d theta is equals to minus e sin theta upon L. Again differentiating with respect to theta, we will get d2u by d theta square is equals to minus e cos theta by L. Now the differential equation of central orbit in polar form is d2u by d theta square plus u is equals to f upon में h square u square. Substituting the value of d2u by d theta square and u from equation number 1 and 2 in equation number 3, we will get f upon में h square u square is equals to minus e cos theta by L plus 1 plus e cos theta by L. Cancelling the term minus e cos theta by L and plus e cos theta by L, we will left with f is equals to h square u square by L. Now substitute h square by L as constant lambda. So f is equals to lambda upon r square. So in this case also force is inversely proportional to inversely proportional to square of the distance of the particle from the focus. Also, in this case, force is attractive as the value of F is positive. Now we will find out expression for velocity. Velocity of central orbit is given by v square is equal to h square into my u square plus du by d theta whole square. Substituting the value of u and du by d theta, we will get h square into my 1 plus e cos theta by l ka whole square plus e square sin square theta by l square. Now h square is our lambda l. Substituting the value of h square, opening the numerator and taking e square common from cos square theta and sin square theta, we will get lambda l into my 1 plus e square plus 2 e cos theta by l square. Now cancelling 1 l from numerator and 1 from denominator, we will get lambda into my 1 plus e square by l plus 2 e cos theta by my l. Substituting the value of e cos theta by l using equation number 1, we will get lambda into my 1 plus e square by l plus 2 u minus 1 by l. Now rearranging the terms in the bracket, we get v square is equals to lambda into my 2u plus e square minus l by r, e square minus 1 by l, and put u is equals to 1 by r, so we get v square is equals to lambda into my 2 by r plus e square minus 1 by my l. Now this is the expression for velocity when the orbit is hyperbola. If 2a and 2b are the length of transverse and conjugate axis and l is semi-lattice rectum of hyperbola, then we have l is equals to b square by a square. We get in terms of eccentricity l is our a into my e square minus 1. So from this term, e square minus 1 by my l will be 1 by a. So in terms of transverse and conjugate axis, v square is equals to lambda into my 2 by r plus 1 by a, which gives the velocity of the particle at any point of its path, and v square is always greater than lambda into my 2 by r, because in this expression we will adding 1 by a, so which is all increasing than 2 lambda by r. So velocity, square of velocity must be greater than 2 lambda by r. Now our next expression is for time period. Let t be the time taken by the particle in describing the whole of the hyperbola, and h by 2 is area described in the unit time. Then what we will have? We will have t into my h by 2, which is rate of sectorial area, rate of change of sectorial area, is equals to area of hyperbola, which is pi a by b. So from here t is equals to 2 pi a b by h. Substituting with the value of h, which is square root of lambda by a, and after that substituting the value of l, which is b square by a square, so we will get t is equals to 2 pi a 3 by 2 upon my square root of l. Thus the time period for one complete revolution is proportional to a ki 3 by 2, where 2a is the length of the transverse axis. Similarly, after doing the expressions for force, velocity and time period when the orbit is hyperbola, we will proceed with the parabolic orbit. The derivation will go on the same steps, so we will switch to the article velocity in a circle. नहीं, अब इस आर्टिकल में हमें क्या बताना है कि सर्कल के अंदर की वेलोसिटी के बारे में बताना है. सपोज हमें ये सर्कल है, सर्कल गिवन है जिसका जो सेंटर ऑफ फोकस है वो हमारा ओ पे है. पी पार्टिकल की पोजीशन है टाइम टी पे. पी पे हमने एक टेंजेंट ड्रॉ किया जिसके अलोंग हमारे पास लीनियर वेलोसिटी वी है. तो जो डेफिनेशन है वेलोसिटी इन अ सर्कल एट एनी पॉइंट ऑफ द सेंट्रल ऑर्बिट इज़ द वेलोसिटी. वो वेलोसिटी होती है जो ज़रूरत होती है एक सर्कल को जब पास करता है एक पॉइंट से जिसका सेंटर क्या हो, सेंटर ऑफ फोर्स एसोसिएटेड विद द ऑर्बिट. ठीक है, ये जो फोर्स होगी, ये हमारी जो वेलोसिटी है, ये टेंजेंट पे लगेगी। सो इस आर्टिकल में हमने क्या ले लिया, जो सेंटर ऑफ फोर्स है वो हमने ओ लिया एज पोल। एफ हमारी सेंट्रल एक्सेलरेशन है विच इज़ डायरेक्टेड टुवर्ड्स ओ एंड ओ पी वेक्टर इज़ अवर आर वेक्टर। वी हमने वेलोसिटी ले ली इन अ सर्कल किसी भी पॉइंट पी के ऊपर। सिंस रेडियस ओ पी वेक्टर वो हमारा नॉर्मल होगा सर्कल के, सो सेंट्रल एक्सेलरेशन, सेंट्रल जो रेडियल एक्सेलरेशन होगी, जो रेडियस के अलॉन्ग लगेगी, वो इनवर्ड नॉर्मल एक्सेलरेशन के इक्वल हो जाएगी। ठीक है जी। सो अब हम इसकी एक्सप्रेशन को देखते हैं। अब हमें क्या पता है, एफ इज इक्वल्स टू वी स्क्वायर बाय रो। जो हमारी रेडियल एक्सेलरेशन है और जो हमारा इनवर्स नॉर्मल एक्सेलरेशन है वो हमारे इक्वल है, और सर्कल के केस में जो हमारा रो होता है वो हमारा आर के इक्वल होता है। सो एफ इज इक्वल्स टू वी स्क्वायर बाय आर। फ्रॉम दिस इक्वेशन we will get v square is equals to rf. Thus in a moving under a central attractive acceleration f, velocity it in a circle at distance a from the center of force is given by v square is equals to af when where r is equals to a. So this is the expression for velocity in a circle. So in next article we will determine the orbit when law of central force is given. Suppose a particle moves in a plane under a central force which varies inversely as the square of the distance from the fixed point. Then we will have to find the orbit. Now what we have given that since the force is directed towards a fixed point, तो हमारे पास फिक्स्ड पॉइंट पे फोर्स डायरेक्टेड है, तो पाथ कैसा हो गया, हमारा सेंट्रल ऑर्बिट हो गया। ठीक है, और सेकंड हमें क्या चीज़ गिवन है कि फोर्स है वो वेरी करे इन्वर्सली एज द स्क्वायर ऑफ द डिस्टेंस ऑफ द पार्टिकल फ्रॉम द सेंटर। सो इस एक्सप्रेशन से हमारा एफ जो है वो हमारा क्या है, इन्वर्सली प्रोपोर्शनल है आर स्क्वायर से। ठीक है, प्रोपोर्शनलिटी का साइन हटा के हमने म्यू कॉन्स्टेंट ले लिया। सो एफ इज इक्वल्स टू म्यू अपॉन आर स्क्वायर। अब हमने डिफरेंशियल इक्वेशन ऑफ सेंट्रल ऑर्बिट की पीडल फॉर्म का यूज़ करते हुए क्या लिखा, एच स्क्वायर बाई पी क्यूब इंटू डी पी बाई डी आर इज इक्वल्स टू एफ। एफ की वैल्यू सब्सटीट्यूट करी म्यू बाई आर स्क्वायर, -2 से -2 लेफ्ट हैंड साइड और राइट हैंड साइड मल्टीप्लाई करा और फिर इंटीग्रेट किया दोनों को both sides. So what we will get, h square by p square is equals to 2 mu by r plus c, which is the required equation of the orbit. So this is all for today's class. Thank you.